Hi there, this video is a quick review of the Chauvin Arnoux CA702 pocket multimeter. I picked this one as a multimeter for the gig tool bag of an electrical guitar player who does not know much about electronics but is faced with the occasional problems of audio cables or pedal power supplies not working, batteries in preamps being flat, fuses blown, extension cables not working and similar gremlins when setting up in different venues. To be of help in these situations, a meter must be compact, robust and simple to use, bordering on pretty much foolproof. Let's see how the CA702 meets these challenges. Well, it's certainly tiny. Just about 10 centimeters or 4 inches long and roughly 5 centimeters or 2 inches wide. In a bright yellow case that has a slightly rubbery texture. There's no IP rating, so despite the rugged looks, you want to avoid getting it wet. As with many pocket meters, the probes are not removable. They can be clipped into holders on the bottom for measuring, or storage, but the tips are still quite close to the front and it's certainly possible to still poke yourself with the probes in the stored position. While the probes are firmly stored, there isn't a good way of storing the wires leading to them. The best way is probably bunching them up and securing them with a rubber band. Okay, normally I do this a bit nicer, but you get the drift. The probes themselves are rated Cat 4 600 volts or Cat 3 1000 volts 10 amps. The material is somewhat flexible, so they can bend slightly. Initially I assumed the protective caps at the tips were removable, but they are not. The meter itself is rated Cat 4 600 volts, which, this being a reputable brand, I have no doubt in believing. This means you could use it safely even in the incoming mains fuse board. Not that you should, but it's good to know the meter protection level is up to it. The battery door is at the rear and held with a screw into a metal insert. The meter needs 2 AAA batteries, which are easy to get, and I much prefer those to the coin cells that other pocket meters use. For safety, the battery contacts are inaccessibly deep inside the meter to prevent shocks in case you left the probes attached to some high voltage, something you should definitely not do. The meter's range switch has only 5 positions in line with keeping it simple. From the left to right we have AC volts, DC volts, off, ohms and a combined diode and continuity setting. All auto ranging only and no current modes, which avoids a large range of possible user errors and confusion. And for what this meter is for, current isn't needed anyway. Very prominently is a useful torch button that works regardless of the range switch setting. On the right is the usual and mostly useless hold function, and on the left a much more useful hold max function for the volts ranges, which also switches between diode and continuity. Above the display is a transparent bar which lights when either NCV or non-contact voltage detection or the volts measurements functions see a voltage above 100 volts. The front has the NCV antenna on the right and the LED torch on the left. The NCV function works without having to turn the meter on, and I must say it works very well. There is no problem finding which of the contacts in this power strips is the live wire. This is indeed a quick way to see if there is mains power. Of course, as with all NCV devices, sticks or meters, absence of this indication doesn't mean it's safe to touch. You should always do an additional measurement to confirm before working on mains. A quick test of AC volts using my Variac with the voltage set to just below 100 volts AC. When I increase the voltage above 100 volts, the red high voltage warning bar above the display comes on. The flickering is a camera shutter effect and not really visible to the eye. I wonder what they use for this. It doesn't seem to be LEDs, more like a gas discharge tube. This AC signal for my DMM Check Plus reference standard is a rectangular wave of 100 Hz. True RMS meters like the XDM 1041 read close to 4.999 volts. Averaging multimeters read 1.1 times higher or 5.5 volts, from which we can conclude that the CA702 is indeed an averaging and not a true RMS meter. Testing a couple of DC values shows nothing remarkable. The accuracy of the CA702 of just 1.2% is of course not setting the world on fire, but good enough for the purpose. It upranges when you reach the 2000 count limit, and once there it keeps that higher range until the value drops to 90% of the lower range. This is pretty standard behavior. I ran a quick test to see if the red high voltage warning bar is working for high DC voltages as well, which would be really handy in a valve-based guitar amp, but sadly no. Here's a test with a mixed AC plus DC signal consisting of a 100 Hz sine wave of 1.74 volts above a fixed DC offset of 4.2 volts. The CA702 has no problems in showing the DC part in DC mode, but when switching to AC, the auto-ranging is trapped in a loop. Similar things happen to many meters, but they usually have a manual range option that gets you out of this. As the CA702 has no manual range mode, you can't use this workaround. In this case, the problem is that the AC voltage needs the 2 volt range and is confused because the also present DC voltage needs the 20 volt range. If the DC voltage is also in the 2 volt range, the meter has no problem measuring the AC. And similar, if we raise the AC voltage so both need the 20 volt range, the meter has no problems. Sadly, in real life, you are generally not able to pick AC or DC voltages to suit the whims of the CA702. The only option is to get an external capacitor, like this 1 microfarad here, to block the DC part, and suddenly everything works as it should. Of course, this is way beyond what I would expect beginners to be able to do, and you would need to make some form adapter to do this safely. Holding the capacitor like I did is only safe for low voltages. And just to confirm, the reverse configuration of a low DC voltage superimposed on a large AC voltage is not a problem. After spending way more time on voltages than planned, let's quickly finish the rest of the functions, starting with the resistance mode. 1 ohm, kind of okay given the limitations. 10 ohms is really slow to settle. 100 ohms, spot on. 1K, spot on. 10K is fine. 100K is fine. 1 meg is okay. 10 meg takes a while but is spot on. 100 meg can't be measured because the maximum the CA702 can do is 20 megs. All in all, no problems with resistance. Continuity next, and oh boy, the CA702 needs a definite contact that persists for a while before it decides to beep. Not ideal in my book, but there we are. I tested the resistance for continuity, the start of which you see here, and I can tell that continuity shows the resistance up to 200 ohms and beeps below 100 ohm. Moving on to diode test, and the CA702 can of course show the forward voltage of a normal diode. But amazingly, not 2 diodes in series. I think this is the first meter I ever tested that can't do that. And it can't even light a single red LED. That's really rather poor. Rigging a replacement diode in form of a 10K pot allows varying the forward voltage, which is really just a voltage drop caused by a fixed current over the resistance of the pot. Raising the resistance increases the voltage until the meter shows OL at 1 volts or higher. That explains why it can't even show the voltage of 2 standard diodes in series, because that voltage will be just slightly higher above 1 volt. Apart from not showing forward voltages above 1 volt, why can't it light a red LED? For that I need to measure the voltage used for the diode test. 1.6 volts is very low, given that the meter runs on 3 volts, probably too low even for a single red LED. Well, if you squint and dim the work lights, you can just make out a faint shimmer in the red LED. But all in all, diode mode is not very good. Luckily, it's probably not needed very often, although just for testing LEDs, it would have been very handy. Since I have the work lights dimmed, I can show you something else that isn't mentioned in the manual. The CA702 has a backlight that illuminates the display while you turn the torch on, which kind of makes sense. It fades out as soon as you let go of the torch button. It might be just some chemical illuminescence layer activated by the light from the torch LED, but then maybe not, because I can't get it to light, shining intense normal or UV light on the display. Another feature that isn't mentioned in the manual is the max function. If you turn it on, the meter will automatically hold the highest AC or DC voltage value measured. In this case, 3.14 volts of the first battery. It keeps working as long as the measurements are higher than the previous one, for example 9.36 volts of the second battery. But of course it fails if you now try to measure a lower value than the one displayed. It won't measure the battery number 1 because we know that value is far lower than 9.36 volts. You have to turn max off and on again to do that. Despite these limitations, max is much more useful feature than the hold function, because you can fully concentrate on positioning the probes and examining the auto hold readout later without having to fumble with the hold button while keeping the probes in position. The last feature is the auto power off. For this, I start the meter and a timer and see how long the meter works before it shuts off. About 14 minutes later, you get a couple of warning beeps. This gives you an opportunity to press any button, for example pressing hold twice to reset the timer. If you don't, then 1 minute later you get one long beep and then the meter shuts off. Now, I don't know about you, but I always wonder how low the off current really is in such cases. The super safe battery compartment makes it really hard, but I managed to rig something that allows us to measure the battery current drawn on the XTM1041. DC volts uses about 0.84 milliamps, which is quite low. At 1.52 milliamps, AC volts practically doubles that, but it's still very reasonable for being powered from two AAAs. Ohms is slightly more than DC volts at 0.9 milliamps, and diode is very similar to DC volts. Finally, the torch comes in at about 2.9 milliamps. I added my priming meter, that way I can see when the low battery indicator comes on and when the CA702 stops working. Just after passing 2.4 volts, the low bat indicator appears on the CA702, but it keeps going with pretty much unchanged contrast until it turns off at about 1.65 volts. That's not too bad and makes good use of the batteries. When shut down or off, the meter draws 0.2 microamps. Well, it's not zero, but quite low. The manual recommends to take the batteries out if the meter is not going to be used for 2 months or more. That's certainly good advice, but who will follow it, I wonder. Using the NCV during sleep makes the current jump to 0.32 milliamps, but notice the bar graph on the priming? Something periodic is going on here. That's why you want a decent and fast bar graph in meters. Replacing the priming with a scope meter reveals the voltage is pulsing at about 50 Hz. This is caused by the CA702 drawing periodically more current, which makes the supply voltage drop slightly because of the burden voltage of the XTM1041 in current mode. The drop is quite substantial, so the current must be large, but the XTM1041 only shows the average. I replaced the XTM1041 with a 10 ohm resistor, and the scope shows the voltage across that resistor. The voltage is about 200 millivolts with spikes as high as almost 400 millivolts. Over 10 ohms, that means a current of 20 milliamps and spikes of 40 milliamps. This is a huge current draw for simple AAAs. There must be some kind of DC converter in the CA702 to drive the red high voltage bar. Maybe this is some kind of fluorescent tube. In any case, we learned now that in the interest of battery life, we should try to have that red bar on as short as possible. I suppose the idea is that the CA702 with its fixed probe leads is always used to measure only momentarily, unlike other meters where you can change the leads to allow a more permanent connection. Finally, here are the specs of the CA702 copied from the manual. It's nothing special. If you want, pause the video and study them in detail. I did add some corrections in red for the diode and continuity test based on my findings. Will this meter work for the purpose I mentioned at the beginning? Probably yes. After all, most of the time it's measuring AC or DC voltages and checking cables and fuses for continuity. Yet I really think this meter could have been so much better if the diode mode wasn't so limited. If you have not subscribed already, hit that button and the notification bell so you don't miss the next video, and maybe consider becoming a Patreon. Link in the description. As a Patreon you get early access to videos, a blog and other exclusive content. Thanks for watching.